Good day, everyone. My name is Alec Tolentino,
And I'm Roland Martinez.
and we will be presenting Activity 1, which is Generate a Pulse Amplitude Modulated Signal in ECE 122 Laboratory. So, modulation. Modulation is a process of changing the characteristic of a carrier signal like amplitude, frequency, and width. It is the process of adding information to the carrier signal. Modulation has two main types. These are the continuous wave modulation and pulse modulation. The pulse modulation's carrier signal is in the form of a pulse or square wave, while the continuous wave modulation, the carrier signal is in continuous form or it is an analog signal. The focus of this activity is the pulse amplitude modulation or PAM. It is the basic form of pulse modulation. According to the book Electronic Communication Systems, second edition by Roy Blake, uh, pulse amplitude modulation is defined as a series of pulses in which the amplitude of each pulse represents the amplitude of the information signal at a given time. Then, amplitude modulation, there are two types of sampling techniques for PAM. These are the flat top PAM and natural PAM. Then, there are two types of PAM, which are the single polarity and double polarity. Single polarity PAM is a situation where a suitable fixed DC bias is added to the signal to ensure that all the pulses are positive, while the double polarity PAM is a situation where the pulses are both positive and negative. So the PAM circuit consists of three subcircuits, which are the sine wave generator, square wave generator, and the pulse modulator. The sine wave generator circuit, it acts as the modulating signal. Then the square wave generator acts as the carrier signal. Then the pulse modulator acts as the multiplier circuit for the two input signals. So this is the block diagram for our pulse amplitude modulation. For the top part is the sine wave generator. Its output is going to the input for the palm modulator, then the square wave generator at the bottom. Its output also goes into the input for the palm modulator. Then in this figure, for letter A is the modulating signal. Then the B shows the single polarity palm. As we can see, it is only at the positive side. Then for the letter C is the double polarity palm, where we can observe that the signals are shown in either the positive side and the negative side. Next is the datasheet and the activity results. So the first step is build a pulse amplitude modulator circuit using LTSpice. Then video record while doing the activity. Use a software that can capture desktop activity while taking video. You may use the sample circuit below or create another circuit with similar outputs shown in the figure. The figure is in the next slide. So for this figure, you can see the message signal, the sampling signal, and the pulse amplitude modulation signal. Step 2 is to take a screenshot of the completed circuit in LTSpice and paste on your lab report. Step 3, simulate the circuit and show output for the sine wave generator, square wave or pulse generator, and palm circuit. Step 4 is take a screenshot of the simulated outputs in LTSpice and paste on your lab report. And the last step is to save LTSpice file and video file for validation. Separate files in Google Drive by folder or by activity. So this is the figure that we will be replicating and simulating into LTSpice. So next is we will be showing our time-lapse videos of us building the circuit in LTSpice.
Hi, my name is Roland Martinez, and this is a video demonstration of the pulse amplitude modulation circuit using the LTSpice. And The circuit that you are seeing in the monitor right now is the preview of the pump circuit, and in this video you will see the design and simulation of the result of the pulse amplitude modulation circuit. After building the schematic diagram of the pulse amplitude modulation circuit, I edited the simulation command using the transient simulation with a stop time of 100 milliseconds and time to start saving data by 20 milliseconds, and a syntax of trans for startup. Clicking OK and running the simulation by clicking the running man or the running button. So first I will show you the output signal of the wind bridge oscillator or the sine wave generator circuit by selecting the output node of the circuit using the probe, and we can see the modulating signal on the result of the LTSpice plotting graph. Then by adding a add plane or a plane, we can add trace of another output signal. So for now we are going to select the square wave generator output signal by using the probe on the output node of the square wave generator circuit. So we can see that the square wave signals are plotted on the graph of the LTSpice. Next, we will add a plot plane for the pulse amplitude modulation signal, and clicking the output 2 or out 2 for the pump modulator signal. You can see the final output or the pulse amplitude modulation signal with a red color. So we can combine these three signals in one plot so that we can differentiate or describe the characteristics of the pulse amplitude modulation. So we remove the plane, and by adding the square wave generator output to the original plane, you can see they are on the same plane. Next is the pulse amplitude modulation signal. You can see that the pulse amplitude modulation signal is varied. The amplitude of the pulse modulation signal is varied to the modulating signal, and the pulse width of the palm is narrower than the square wave signal, where it only appears on uh, low low state of the square wave signal.
Hello, my name is Alec Tolentino, and I will be demonstrating activity 1. So activity 1 is generate a pulse amplitude modulated signal. Pulse amplitude modulation is where an analog signal is sampled at regular intervals, and each sample is converted into a pulse with varying amplitude. The main application of PAM is in analog to digital conversion of signal, such as in PCM. So we are to build a pulse amplitude modulator circuit using LTSpice. Then we are to simulate the circuit and show the outputs for the sine wave generator, square wave or pulse generator, and the pump circuit. So now I will now be building the circuit. So as we can see here, the produce the output for the palm modulator. Again, I'll separate it. The output for the palm modulator. Then we will include the modulating signal. So as we can see, uh, the results of the palm modulator, the peaks forms into the modulating signal. So this means that it is a natural pulse amplitude modulated signal. Then we will also display results for the square wave generator, which represents the red lines. So again, I will separate the results for the uh, pump modulator, then the modulating signal, then the square wave generator. So that is all for my demonstration for activity 1. Thank you.
Next is the datasheet activities results. In this figure, you can see the schematic diagram using LTSpice of the pulse amplitude modulation circuit. It consists of the sine wave generator. You can see on the top part, the wind bridge oscillator circuit or the WBO circuit that generates sine wave. Then on the bottom part is the square wave generator that generates pulses. And on the right side is the pulse modulator circuit, which multiplies the input signal of the sine wave and the pulse wave that creates a pulse amplitude modulation circuit signal. It uses a NPN transistor for the pulse modulator. You can see in the figure the sinusoidal modulating signal where it is generated under the WBO or wind bridge oscillator. It has a 52.9 hertz of oscillation frequency, where frequency of oscillation can be computed using the formula of frequency oscillation, which is equal to 1 over 2 times pi times the RC, where we use the two RC networks or the feedback networks. The two RC network consists of the low pass filter and high pass filter or the phase shift network. So you can see in the schematic diagram that the uh, phase shift network is in the lower part of the sine wave generator or the WBO circuit. So the phase shift network results in a phase angle of 0 degree. Next is the uh, square wave generator uh, result, which plot a square wave or the pulses on the LTSpice. You can see that the generated pulses has a 577 microseconds for the high state, and for the low state is 295 microseconds, as can be verified in the time lapse video. So next is the uh, output or the pulse amplitude modulation signal, where the inputs such as the sine wave and the modulating signal and the uh, pulse or square wave signal is multiplied in the pulse modulator circuit, and the amplitude of the carrier pulse train is varied using the amplitude of the modulating or the message signal. So to verify that the amplitude of the modulating signal is varied the carrier train pulse, we can see that the blue lines or the sinusoidal wave envelopes the palm signal. A narrower pulse in the green line, a narrower pulse width is observed, which means a palm has a low duty cycle. So you can see in the figure the three outputs of the three subcircuits of the pulse amplitude modulation circuit. In summary, the palm is the product of the modulating signal and the carrier pulse train. We can observe the modulating signal in sinusoidal form in green line, And the carrier pulse train in square wave or pulse in the second or in the middle plot, which is a blue line, and the palm signal in the double polarity palm, which has a positive and negative peaks in red color line. So the positive and negative peak amplitude in pulse mode varied by the modulating signal. The resulting signal of the two input analog signal is still in analog signal. So in conclusion, PAM is the simplest form of pulse modulation, and the output signal is still an analog signal. To produce a PAM signal, a circuit must consist of a sine wave generator, square wave generator, and the pulse modulator. Sine wave generator produces the modulating signal or the message signal, while the square wave generator acts as a carrier pulse train or the carrier signal, and the pulse modulator is the multiplier of the modulating signal and the carrier pulse train signal to produce a palm signal. It is observed that in pulse amplitude modulation, a series of pulses in which the amplitude of each pulse represents the amplitude of the information signal at a given time. A train of very short pulses of constant amplitude and fast repetition rate is chosen. The amplitude of these pulses is made to vary in accordance with that of the slower modulating signal, and the result is that of the multiplying the train by the modulating signal that envelopes the pulse height corresponds to the modulating wave. And the palm wave contain upper and lower sidebands frequencies besides the modulating and pulse signals. And the pump produced by the circuit used in this activity is double polarity, where pump signal, because it is employed pulses of positive and negative polarity, and the average value is equal to 0. In natural pump, the amplitude of each pulse has a direct relationship to the modulating signal amplitude at the time of pulse occurrence. In PAM, the signal amplitude can be changed based on the modulating signal through multiplying the carrier signal with the modulating signal. The resulting PAM signal of the circuit is a natural PAM, since each pulse is directly proportional to the modulating signal amplitude at the time of pulse occurrence, then follows the amplitude of the pulse for the rest of the half cycle. It is also observed that the modulation produces a series of pulses with a constant width, and the pulses are narrow compared to the period of sampling of the square waves. So we can observe also that the duty cycle of the pulse amplitude modulation signal is low since the pulse width constant is narrow. And that's the conclude our presentation.